Did you know that every day you use between 80 and 100 gallons of water? All of this water goes down the drain and ends up flowing out into rivers, creeks, and oceans. The potential for electricity generation for all that water is actually quite significant. Reclaim Energies is using turbines to put a new spin on a traditional technology and utilize the power of gravity and to bring hydroelectric power to generate electricity from this discharged water. This novel application of conventional technology will allow us to revolutionize the reliance of large industries in renewable energy. Join us in creating a greener tomorrow. Reclaim Energies, optimizing the capture of untapped hydropower.
Hi, I'm Melanie, and this is Toby, and we are the co-founders of Reclaim Energies. As you saw from our video, we no longer need a dam or a big river to generate hydropower. All we need is a constant flow of water that is gravity-fed. But why is new hydropower important? Most scientists say we have 12 years to radically change the way we generate electricity before we cause irreparable damage to our environment. This is Reclaim Energy's core mission, to open the door to a new avenue of untapped hydropower in order to help preserve our planet. One of the biggest sources of untapped power today in our world is wastewater treatment plants. As you can see in this picture, these facilities handle billions of gallons of water per day that are all gravity-fed out to a nearby body of water, making it perfect for electricity generation. Wastewater treatment facilities face a threefold problem. 1, they run 24/7 and have extremely high electricity bills. 2, new government mandates are forcing states to increase their reliance on renewables. For example, in New Jersey, only 5% of the state's electricity bill comes from renewables, but they are forced to increase this to 50% by 2030, which is 10 years away. And lastly, most renewables don't make this economically viable for every industry.
And that's where we come in. Not only are we going to decrease electricity costs for these facilities in a manner that's economically viable, but we'll also do so in a way that allows them to begin to satisfy some of these government requirements. We're a team of civil and environmental engineers sponsored by the Princeton Student Climate Initiative and backed by a body of acclaimed advisors who possess a wealth of relevant experience, not only in business and finance, but also turbo machinery, fluid mechanics, and electricity generation systems. The technology behind what we're doing isn't anything new. In fact, it's quite ancient, and it's called the Archimedes screw turbine. It was developed by Greek mathematician Archimedes over 2,000 years ago, and the beautiful thing about these turbines is that they use the weight of the water rather than how fast the water is moving through them to generate electricity. This enables the turbines to be 90% efficient, work in variable flow rates, and work in pipes that aren't completely full, making them versatile and well-suited for all our applications. These turbines,
Sorry, my bad.
You're good. These turbines will be placed at the ends of the outfall pipes of these wastewater treatment facilities, and they'll be 3D printed on a large scale using a company known as Cosine Additive. 3D metal printing our turbines enables us to cut down costs and implementation times by as much as 50 and 75% respectively, as compared to traditional factory methods. So how do we stack up against other renewable options? Well, unlike other options that are either intermittent, have high capital costs and implementation times, and cause some form of environmental damage, our solution is completely eco-friendly, works 24/7, has much lower capital costs, and can be implemented in as little as 2 weeks. Looking at our total addressable market, there are over 18,000 wastewater treatment plants in the United States, representing an almost $2 billion market. For now, we'll be focusing on the 142 in New Jersey for our proof of concept and to establish ourselves in the market, after which we'll expand to the 700 plus in the Northeast area. We're going to contact these facilities using lists provided by the EPA and other local environmental authorities. Once these facilities have displayed interest in our technology, we'll do an on-site analysis to assess the feasibility of our tech at their site, as well as provide a quote that specifies how much electricity they'll generate, how much money they'll save, and how much the system will cost. The contract they sign will stipulate that they pay a portion of the costs up front, and then the rest after the installation is completed. Even after the installation is completed, we still have a couple of options for revenue streams. One is maintenance over a period of time specified by the customer, whether it be 5, 10, or 20 years. 2 is to take a percentage of the electricity profits. So let's say a facility saves $20,000 a year on electricity, we'll take 10% of that and get $2,000 every year from that facility. Finally, a third and really lucrative option is to use these turbines essentially as battery chargers. And what they'll be charging are emergency standby batteries that can be used in the event of an unplanned power outage. This enables us to not only sell guaranteed power output to these facilities, but security and peace of mind.
These past few months, we have made significant progress. We've partnered with a company that will 3D metal print our turbines, identified contractors for our installations, and gained support from the EPA and other local environmental authorities, which enable us to get in contact with 80 wastewater treatment plants all over New Jersey. Right now, we are currently closing in on 4 potential partnerships for our first implementation. Overall, we received positive feedback from these wastewater treatment plants, some telling us they've been waiting years for technology like this. One of our potential partners lies in southern New Jersey and discharges 10 million gallons per day. Here, our turbines will generate 19.2 kilowatts of electricity, which correlates to $23,000 in electrical savings per year. This will give us an initial net profit of $97,000 for a customer investment of $170,000. As mentioned before, if we choose to take a certain percentage of electrical savings, we will also receive $4,000 per year while maintaining an IRR of 12%. I know you must be saying that $170,000 may seem like a lot, but we've talked to some wastewater treatment plants that have invested millions of dollars in other renewables, such as solar or sludge to biogas, that didn't give them good returns for their investment. Once we have finalized a partnership, we will go through with our proof of concept. This will be made possible through grants and investment fundings in 2020. Once this proves to be successful, we will sell to 3 wastewater treatment plants in the second year and 8 in the following year. If we continue along this trend, we will sell to 46 wastewater treatment plants in 5 years, which will give us a revenue of $5 million in that 5th year.
To make this possible, we're asking for an initial investment of $200,000 for our proof of concept and to implement with our first wastewater treatment facility. We hope you join us as we create a greener tomorrow and as we optimize the capture of untapped hydropower. Thank you.
Great job. Thank you. Can you talk a little bit more about these wastewater treatment plants and their, aren't they usually part of like a municipality, or just tell me a little more about the structure and their decision-making process? I guess where I'm going and what I'm concerned about is how they can make these kinds of decisions, what they're going to need from you that still hasn't happened before they'd be ready to do that. So talk a little bit more about that.
Right. Cool. Yes. So these wastewater treatment plants, like you said, are managed by municipalities, and we've talked to them a lot about what their sales cycles are, or at least what their funding cycles are and what that means for us with our sales cycle. A lot of these facilities have anywhere between $100,000 to $1 million on a yearly basis for what they call facility improvements that the managers can use however they see. And so we really see that coming, we really see ourselves sort of inserting into that budget. The decision making for them takes about 2 months usually. So our sales cycle will probably be around 4 months for per customer.
Thank you.
Yep.
Has this been done any place?
Yeah, so this has actually been done in a variety of places before. This is predominantly a big market overseas in Europe, and specifically in New England, in the New England area, where this has proven to be successful for wastewater treatment plants there. And there's actually been studies done in New York on the wastewater treatment plants there that discharge a lot of water to try to get positive returns for their electricity, because they're using a lot of electricity per month, whether that be like roughly $100,000 all the way to $1 million a year.
So what are you doing differently than they are?
Yeah, so in the United States, projects like these aren't pursued primarily because of the economic feasibility rather than the technological feasibility. So one of the things we're doing is we're 3D printing our turbines, and that takes a cost for like the facility in New Jersey, for example, the southern New Jersey that we talked about. A turbine for them would cost anywhere between $50,000 to $60,000. 3D printing it brings that down to $23,000. And then the second thing, is that a lot of times when you look at hydropower projects within the U.S., they cost anywhere between $300,000 to $500,000 in permits, and that's sort of dissuaded a lot of hydro companies from looking into hydropower on this scale. We talked to a FERC representative of the Federal Energy Regulatory Commission, and we're actually exempt from that. So a lot of these companies have looked at the U.S. and said, oh, that's not valid at all because of these sort of high permit barriers. But we've done the legwork of actually talking to the FERC about that, and we'll be exempt from that, so making these installations much cheaper for us and making them much cheaper for the customer as well.
And just to clarify, the reason why we're exempt from it is because we'll be a part of the facility rather than in the environment, in the rivers, in the creeks. And as well, one of the biggest exemptions is that we are at a lower power output. So usually people that get permitted are on the megawatt scale, meanwhile we're on the kilowatt scale.
Thank you.
No problem.
And great job.
Thank you.
Talk about the use of proceeds. How do you plan to spend the 200K? And typically for a project like this, I would imagine you need to build something like a pilot line so that you can demonstrate the technology works and the ROI itself.
Exactly.
And how do you think about going from there to get some POC going?
So the $200,000 is entirely just for our proof of concept. It's not taking into account sort of the ways that we'll grow after that proof of concept, but you can see an itemized breakdown of what goes into sort of implementing for that first time. And a distinct thing to notice is that for the turbine, for that proof of concepts, we're actually just going to outsource the turbine as opposed to build it ourselves. So it's a much more expensive turbine to build, but that's what the 200K will go to.
And as mentioned before, these turbines have been around for centuries. It's not like we're trying to prove that this turbine works. The turbine does work, but the application has been emphasized enough. So it's this use technology repetitively that is just being put in a new place.
Good. Well, sometimes the simplest solutions are the best, so I congratulate you on picking something. I mean, with wastewater, you can see the
Thank
energy
you.
there, so capturing it is excellent. Is the turbine separate from the electrical generator, though? Are you selling both or just one?
So what we're selling is the service of bringing decreased electricity costs to these facilities. We're doing a lot of assembly on our end, connecting a turbine vendor, a contractor, the gearbox provider, the generator provider. So they all won't come from the same place. We'll pre-assemble all of that, show up to your site, drop it in,
So your
install
cost
it.
saving is on the turbine. It's not on the electrical generation unit, though. That's still a standard off the shelf.
Yes.
Yeah.
Okay. All right. Great. And I congratulate you on the pricing option of taking a profit share
Yeah.
on the cost saving. That's a very good idea. It's a great business model.
Thank
And it's also recurring, right? That
Yes.
check keeps coming in every month. So that's terrific. You've got that in your model.
Yeah,
Thank
and,
you.
and I'm glad you mentioned that too, because one of the business strategies we're playing with is actually have the customers not pay anything for the installation. We come in, we cover the cost of the installation, but then we keep an even higher share of their electricity profits.
Yeah, but
and-
you got to get the cash. So.
Exactly.
Yeah,
So that'll
yeah,
take
yeah.
a lot of bank
Yeah, no,
financing.
exactly.
Good. Great presentation.
Okay,
Thank
thank you
you.
so much.
Good idea.
Okay.